Oops, I'm going to close that. Hello, and welcome to part 2 of our video lesson series focusing on the nucleus. In this second part, we are going to dive deeper and look at isotopes. Now, isotopes is a new word, but it's not a brand new term. So we have actually been talking about and teaching isotopes way back from Unit 1. We just hadn't correlated the vocabulary to it. Now, all an isotope is 2 or more, so I'm going to use the symbol 2 plus, of the same element with varying atomic masses due to varying numbers of neutrons. All right, what does this mean? Well, let's look at a picture. I am going to draw 3 nuclei. And inside these nuclei, I am going to place 92 protons and varying numbers of neutrons. So let's say in my first one, I'm going to do, one second, let me make sure my math is going to work, 140. So I'm going to do 140 neutrons in my first, 146 neutrons in my second, and then 148 neutrons in my third. Now, if I was going to continue with our last discussion and work backwards, I could build an element card for each of these different nuclei. However, my element cards are not going to be that different because when I start to construct them, I can very quickly see a similarity. All 3 of these nuclei have 92 protons. That means all of these elements are element 92. When I go to look them up, my card is going to look very, very similar. I'm going to pull out my periodic table. I'm going to find element 92 and discover that all of these nuclei are uranium. The only thing that is going to be different is my atomic mass at the bottom. For my first element, my atomic mass is going to be 140 plus 92, or 232. Let me see if I can get everything in here. For my second element, I have 92 plus 146 for an atomic mass of 238. And in my third element, I have 92 plus 148 for an atomic mass of 240. These are all isotopes. Same element, different mass. This is why we do isotopes when we talk about the nucleus. We're looking at different versions of the same element. Every single isotope will have the same number of protons when we're talking about uranium. Every single atom of uranium has 92 protons. However, that number of neutrons is not consistent. Sometimes there's more, sometimes there's less. Changing that number of neutrons changes the mass, which gives you different isotopes. Now, if you remember clear back from Unit 1, this is why we do element symbols as name, dot, or dash mass. Because this lets us differentiate between isotopes. Now, a couple of you may be asking, well, which mass goes on the periodic table? Am I going to put 232? Am I going to do 238? Am I going to do 240? And the answer is indirectly all of them. When we built the periodic table, you don't pick just one mass to put on there, you put on a weighted average. So, what that might look like for uranium. Uranium is a metal. It's found in rocks. It's found all over our Earth's crusts. Now, we're going to say that you are a scientist. You have gone out and you have dug up a rock. You take it back to the lab, you analyze it, and you realize that you have collected 105 uranium atoms, which includes 4 different isotopes. And you are going to organize your data into a table. Now, these are all uranium. The first isotope you collect has an atomic mass of 232. You found 12 atoms with an atomic mass of 232. Then you go to your next atom on your list, and it has an atomic mass of 236. And you find a lot more of these. You find 40 atoms with an atomic mass of 236. Then you figure out that there are some uranium atoms with a mass of 240. You find 20 atoms with an atomic mass of 240, and then you find a rather light isotope with an atomic mass of 224. And you have 33 of these atoms at your lighter isotope. And this is your data. You've gone out to the field, collected 4 different isotopes, and counted the number of atoms with each isotope. If we want to double check ourselves, we have 12 of isotope A, 40 of B, 20 of C, and 33 of D. I have 105 uranium atoms total, which is what I had originally counted up. Now, to take a weighted average, you're basically going to figure out what is the input of each different isotope. So you need to calculate the abundance. Just from eyeballing it, I can see that I have a lot of atoms at 236. That is my most abundant isotope of uranium. 40 of my 105 atoms are uranium-236. 12 are 232, 20 are 240, and then 233 are, and then 33 of them are mass 224. Now I can actually see here, I made a little oopsie. Your abundance is always going to be calculated as your total number of atoms for each isotope, so 12, divided by your total atoms. So it's your atoms of each isotope divided by your total atoms. So it's 12 divide 105, 40 divide 105, 20 divide 105, and 33 divide 105. You're going to figure that out as a percent. So just actually go through and divide them. And I am actually going to keep my percent as a decimal. So I have 0.11% here, or 11, 0.38% here, 0.19 here, and 0.31 here. Now, you should always double check yourselves. These are percentages. They should add up to 100. So 0.11 plus 0.38 plus 0.19 plus 0.31 is 0.99. So with rounding, I am near my 100 percentile for abundance. Now, almost done. All that's left to do is take your mass and then multiply it by your abundance. So my mass here, this is uranium-232. So this is 232 times 0.11. This is 236 times 0.38. This is 240 times 0.19. This is 224 times 0.31. I'm going to put all of those in my calculator. 232 times 0.11, 25.52, 236 times 0.38, 240 times 0.19, and then 224 times 0.31. Wow. Add those up. And I get a mass of something not right. Okay, so double check yourselves. I got a total mass of 290, which is bigger than all of my isotope masses over to the left. So something went wrong here. I'm going to double check and make sure it wasn't some button pushing. So 25.52, 89.68, 45.6, and 69.44. It was some button pushing. So my total mass is 230.24. Now, it always makes sense to kind of double check. That is within range. I've got this really light one here that's going to pull my average down, but I've got 230, which is right around where most of my atoms are. I've got one lower than that. I've got a couple of higher, but that is within my correct range. So this is all sheet 3 is. Working through some isotope calculations. Get that abundance, get it as a decimal, take your percent abundance, times it by your isotope mass, and total them all up.